discuss about algebra today. Okay, so I'm going to give 1. Okay, this is 1. Can you write 1 in terms of x?
1 into x.
I want to write 1 in terms of x. 1 is equal to something where I need to get some x there. I need to see some x.
Or maybe x into 1.
X into 1 is become x.
X.
1.
Huh?
6. 0 into x.
0 into x will be 0.
1 by x.
1 by x will be x to the power of minus 1. 1 by x is not 1. 1 to the power of 0, there is no x in it.
There has to be x.
There has to be x. 1 into x will become x.
X రావాలి కాకపోతే
Okay, there it is, x to the power of 0.
Oh.
Okay, that is one way. See, in this expression, we have x. Similarly, there is also another way where you can do like this. 0 into x.
Yeah.
This is also 1, isn't it? 0x are 0 plus 1. Okay.
Wait.
Okay. These are the
no,
things.
it's-
Whenever there is a need, you need to apply it. Okay. Okay. For example, somebody may say it is x to the power of n. What is the y term here? Can you put in
0.
some y term here? You can put a y term. Say something like
0.
x to the power of n into y to the power of 0.
Yeah.
For the sake of putting, you can put it if you want. Okay. This is still x to the power of n. Okay. There is no change because y to the power of 0 is 1. So when you multiply x to the power of n with 1, you will get x to the power of n. Okay. Okay. So let's do. Okay. So you know what is NCR, right? Okay. Let's revive this one. NCR is equal to n factorial
That's a
by
binomial expressions.
n minus r factorial into r factorial. Okay. How do you? What is the formula for n factorial? N into n minus 1 into n minus 2 into so on, so on, so on until 1. Okay. Don't go to 0. Otherwise, it's going to become 0. Everything. So n factorial is n into n minus 1 into n minus 2 into n minus 3 into so on, so on, so on until 1. Okay. There won't be any negative numbers here in NCR. There won't be any negative numbers here, here, here. Okay. R should always be less than n. Okay. It can be 0. R can be 0. R can be 0, but R should never exceed more than n. Okay. So other identities when it comes to this factorials is 0 factorials is 1. Okay. 1 factorial is also 1. Okay. Okay. So the factorial is, for example, 5 factorial. If you want to compute the value of the 5 factorial, you have to multiply 5 into 4 into 3 into 2 into 1. Okay. Say if it is a 2 factorial, 2 into 1. For example, n factorial, you can also write n into n minus 1 into n minus 2 into n minus 3 factorial. You can write it this way also. Okay. You can write this way also. N into n minus 1 into n minus 2 into n minus 3. Is it right or wrong?
Yeah.
You can write it right.
That's right.
Okay. This is especially useful when you are calculating this kind of NCR expressions. For example, I'll give you 5C3. The best way of calculating this one is, what is the formula for 5C3? 5 factorial
5 factorial
by 5 minus 3 factorial into
3 factorial.
3 factorial. Okay, the 5 factorial you can write as 5 into 4 into 3 factorial. I'm going to stop it here because I don't expand it to until
You
1.
cancel 3 factorial.
Yeah, exactly. Yeah, the reason why I stopped here is that because I already have a 3 factorial here, which I can cancel this one, and 5 minus 2 factorial
2
is
factorial.
2 factorial, which is 2. 2 into 1, that is 2. You can put 2 into 1 or 2. 3 factorial gets cancelled, 2 goes in 2 times.
Can't you write it like this? 5 into 4 into 3 into 2 factorial.
Yeah, you can write it. But again, you have to write one more
But this
number,
2
right?
factorial and 2 factorial gets cancelled.
Yeah, 2 factorial gets cancelled. But the reason why I stopped is because this is the biggest number. That's it. Okay. So 5 2s are 10. Okay, this is how you have to compute NCR value, any NCR value. Okay, the rules are 0 factorial is 1. This is an identity. Okay, there is no proof like why, how we got it, how we got this 1, but you simply have to remember 0 factorial is 1, 1 factorial is 1, and 2 factorial is 2 into 1, and NCR is very much useful in a binomial expression, binomial expansion, which we'll see later. But yeah, R should always be less than.
But what are those identities that you told?
These are the identities. 0 factorial is
0
1.
factorial is 1 and 1 factorial is 1.
Yeah, 1 factorial is simply you can do it yourself. Like 1 factorial is 1 into. That's it. Because the 1 itself is the least
But
number.
how 0 factorial?
0 factorial is a 1. That is an identity. That is why I said it's a postulate. It's an identity. Okay. Okay. There may be some derivations to prove 0 factorial is 1, but that is all at a higher level math, not at this level. Okay. So n factorial by n minus r factorial into r factorial. All right. Okay.
N
So before we go,
factorial by n minus r factorial into r factorial or minus r factorial?
r factorial.
Into
Okay.
R factorial.
NCR, you'll never get a negative value for it. You'll never get a minus 5. The answer is always a positive. N is also positive, R is also positive. Positive as in, like, it can be maximum of 0. It cannot be more than, it can't be less than 0. It should not be decimal values. It should not be 2.5, C, 1.5. This is wrong. Okay. These kind of expressions will never exist. Okay. All right. So this is one expression, a square minus b square. What are the factors of it?
A plus b into a minus b.
A plus b into a minus b, exactly. A plus b
into a minus b.
into a minus b.
There is no formula for a square plus b square.
There is no formula for a square plus b square. Yeah,
Yes.
it's not a formula. That is an expression,
Yes.
but there are no factors instead of that. You can
Oh.
say, as such, it is. I don't consider this as a formula. Just writing this one in terms of 2 factors. These 2 factors, if you multiply it, you will get it a square plus b square. Shall we do that? A into a square, a into minus b, a into minus b, minus
So
ab,
minus ab
plus ab,
minus b square.
minus b square, plus
Plus
ab,
AB
minus ab
minus
got cancelled, you got a square minus b square. As simple as that. You don't have to waste your memory to remember this one. Okay. Similarly, there is also some formulas. Okay, before that, let's do it.
But what if they gave you a square minus b square and you have to find out the factors for it? How will you do if you don't know the formula? Like if you don't know that one.
Good question. So the expression is already given, and they are asking you to find the factors.
The factors. I think you can do it like
Yeah, you can do it that way. Quadratic equation, is it? That's a good question. Yeah, how do we get this idea?
but usually there isn't formula. No, we can like.
Yeah, what I mean to say is, like, these kind of formulas, you don't have to spend too much of your memory to remember this one, but instead of wherever you get a doubt, you can simply
If
multiply
they
it.
give you a plus b into a minus b, then you can tell it is a square minus b square because.
Yeah, a plus b into a minus b. Yeah, but if they give you a square minus b square, that's a good thing. Yeah. So in that way, you have to remember. Yeah. Okay. You're doing good. You're doing good. Great. Okay. So I also have another thing. Say a minus b into a square minus ab plus b square. Let's do this multiplication.
It is a cube.
Okay. A into a cube. A into minus ab. What is the value of that one?
Minus a square b.
Very good. Yeah, minus a square
Not
b.
a minus ab square.
Exactly.
It's
Yeah.
different.
A into next one
Is
Plus
A
ab square.
plus ab square. Okay. Let's
Minus b
move.
a square.
Minus b a square
Plus ab square.
plus
Plus ab square.
super.
plus a b and
Minus b
plus
minus
ab
b cube.
square.
You can
Okay.
rearrange by like.
You can rearrange it exactly. Yeah. A
Minus
square
b.
b. Let's put a term first and then b term.
No, you can put like cubes at the first instance.
No. Yeah, you can do it, but let's put this way. These terms contains, this is a term. You know, a term is something which is separated with a plus or minus. Okay. So this is a minus. Where is again next plus or minus here? So between these two is a term. So this is one term. Because we have plus here and we have minus here. Between these two is a term. Similarly here. Okay. So let's put a term first. So this one, if you want to put a first, how can you rewrite this one?
Minus a square b
Minus a square b
plus ab square.
plus ab square. Okay. B cube. Okay. Can we cancel out anything here?
No.
Minus no.
Why?
Minus
A square b minus a square b plus s plus
No, we
That's
can't.
ab square.
plus a square.
No, we can't.
Are you sure?
Yes.
Yeah, we can't.
I think we
Parting,
did.
I
Oh,
thought
okay.
is
All right,
same
yeah.
one.
So there is nothing to cancel here, right? Okay.
Yes.
Let's leave it like this. You can further simplify it. A cube minus 2
Add it.
2 a square b. Okay.
Okay.
A square b minus a square b minus a square b plus
Plus
2ab square
minus b cube.
minus b cube.
That is.
Okay. So when you multiply this one, this is the formula. Okay. Let's do another multiplication wherein I have a minus b, a square minus ab plus b square. Okay, let's do it.
No,
It's
that
exactly the same. Sorry, it's the same only, right? Yeah, a plus b into. So what is the difference between this multiplication and this
That's
multiplication?
a minus
That
b
is-
and
Yeah,
this is
here it is a minus b,
is
here
a
we have a
plus
plus
b.
b. Okay, let's quickly do it. A
I
cube.
think how it will come means
Minus a
before
square
b,
b.
it will come
Yeah,
plus
let's do it quickly. Yeah, tell along with me.
a cube minus
a
a square
plus
b
b
plus
a
a
square minus a b square minus b cube. Okay, if you rearrange this one, a cube minus
we
a square b
cancel. Yeah,
minus a square
we
b
can
plus ab square
cancel.
plus a square b minus ab square minus b cube.
We can
Yeah, can we cancel a square b here minus a square b
yeah,
plus a square b
yeah,
plus ab square
yeah.
minus ab square.
Yeah.
So what are we left
a
with?
cube minus b cube.
A cube minus b cube. See, for a cube and a cube minus b cube, these are the factors.
Mhm.
These are the factors.
Yep.
Okay.
Is a
See-
cube minus b cube the same as a minus b whole cube?
A cube.
No,
Minus b cube the same as a minus
Yeah,
b
but-
no,
whole
it's
cube.
not.
Never.
No.
Okay, it's not at all. Okay. Not at all. Okay, so this is another formula, I would say. Maybe you can remember. Okay, so if something is given like this, these are the two factors.
Mhm.
These are the two factors. Okay. Yeah. So there is also another formula, a minus b, a square plus ab plus b square. Is this that one? No, I don't.
Hmm?
Okay. So if you expand this one, you get what? How about this one?
What you want to get at the end?
Okay. There are also factors for a cube plus b cube.
Oh,
So what are those factors?
see that's like
Okay.
if you
A cube minus b a square. Okay, let's look in the textbook. a plus b, a square minus ab plus b square. A square minus ab plus b square. A cube plus b cube. Oh, there you go. You did a mistake here. Plus b into plus b square. What is that one?
Plus b cube.
Plus b cube.
Oh.
Okay, so this is a cube plus b cube. And this is for a cube minus b cube.
Yeah.
If you
Okay.
expand this one, you get a
Okay.
cube minus b cube. Okay, for a cube,
The
Minus
only
b
difference
cube.
between that one and this
yeah,
one is
here we have a
plus.
plus, here we have minus, whereas here we have minus, here we have all plus.
yes.
Okay, a cube minus b cube. This is also same as this one, a square minus b square. What are the factors for it? A plus b into
A minus b.
a minus b.
Yep.
Okay.
Mhm.
Yeah. Okay. Okay. So on the similar lines, a question can be asked like p minus 1 into p square plus
p.
p plus 1.
It's not plus p. It has to be like plus.
It's the
one.
same as that
Oh
one.
yeah.
Mhm.
Okay.
I think it is p cube minus 1 cube.
One cube,
P
yeah,
cube
p-
minus 1.
P cube minus 1. Yeah, you can multiply it. If not, you can use this one. Okay, if not, you can use this one. All right. Okay, so let's do a few more. Two root
Oh.
3. What does it mean? It's 2 into root 3.
Two
Okay.
Yes.
root three.
2 root 3 minus
Mhm.
6 root 2 into 2 root 3 plus 6 root 2. Can we simplify this one?
Yeah, it's same like a minus b into a plus b.
Exactly. Yeah. Okay. A minus b into a plus b. What is the formula for it?
A square minus b
plus
square.
two.
A square
No.
minus b square.
A square minus b square. A plus b into a minus b. So I put it in a different
Yeah,
way.
yeah.
A minus b into a plus b. Both are same, right?
Yeah, I thought it's actually a square plus 2ab.
Okay. So a square minus b square. What is a here?
Two
Two,
square,
uh,
square
two
root
root
3.
2 square 3.
A square. What is b here?
6 square root
Wait.
2.
Minus
No.
6 square root
Exactly,
2.
yeah. A square minus b square. B is this one. Square. Yeah. Can you tell me like what is the square of
Actually,
this
you
number?
should have given 2 root 3
Hmm.
plus 6 root 2.
Yeah, I
two
would have
root
given, but that is why I reversed it, whether you are able to
Yes.
spot this pattern or not. Okay, this is a pattern wherein the multiplication of two numbers, they follow a plus b into a minus b formula. Okay, yeah, okay, so what do you get when you evaluate this number? 2 root 3 whole square.
2 cancel.
Oh,
No.
You can see in calculator what is 2 root 3. You'll get something and then square it.
so, what is this one? AB whole square. Is this not a square b square? It is same as this one,
Yes.
right?
Yeah.
Is it 2 square 3 square?
Exactly. 2 square root 3 square.
But that's not into, right?
This is into.
Yeah,
That's what I
it
said.
is
2
actually.
root 3, which means it's not a square root of 3.
It's just 2 times 3.
2 times root 3. 2 times root 3.
Oh, okay, okay.
Okay. So,
Okay, okay.
is it clarified?
Yeah.
Yes.
Okay. So, this one. And how about this one? How do you evaluate this one? 6 square.
6
Square
square.
root and square can be
Exactly. Yeah. So, at this stage, a square root and square can be cancelled.
So 2
2
square
square
into
is
3.
4. 4 into 3
3 minus
minus 36 into
36 into
4. 3 4s are 12.
12 minus
Minus 24, 2, 12, 144.
That's a negative number.
It's a negative number, yeah. 2, 3, 1, negative. Yeah. Okay? Minus 132. That's how you have to calculate.
Yeah.
Okay? Alright, yeah. We'll pick up one more sum. ax plus ay minus cx minus cy by x plus ay plus cx plus cy. So can you think of any ways that we can simplify this one?
We
need to
can't
simplify
we
this.
can't cancel because that is
Yeah, we
present.
can't cancel it.
Take common of
Cancellation can only be done if there are the straight multiplication in the numerator and straight multiplications in the denominator.
you can't take anything
Okay, for
common as
example,
well.
if something like this, 7 into 9, then only you can cancel it. Whereas if I put a plus here, you cannot cancel this 7 and this 7. Okay? Okay,
You
so
can't take a common, you can't take x common, you can't take.
you can take a common across all terms, I agree. But can we take a common
maybe
between these two
x-
terms?
Yeah, we can. Yeah.
maybe.
So a bracket x plus y
X plus
minus c bracket x minus y.
No,
No,
X
x
plus
plus
y.
a x.
X plus y. Got it?
Yes.
By what can we take a common here? A x plus y and then plus c
C x plus y.
x plus y. Can we take
I
anything common
have a
here?
doubt why a plus came there.
This one,
Plus yes.
minus into plus,
Oh.
minus into plus,
Okay.
minus c
Okay,
into
okay.
x, minus cx, minus c into y, minus cy.
Oh.
Okay. Similarly down here plus c x plus cx plus cy. Okay. Okay. So can we further simplify it then?
You can cancel a.
Can we cancel a?
No.
That's what I said,
We
right?
have
Because we
to-
have a minus here, we have plus here.
Oh yes.
There are two terms here. It's not a single term.
What
Okay,
you
only then you can cancel it.
Take
That's why I am explaining
common
again.
by
7
x
8
plus
into
y.
1 by 2 plus 8. Can we cancel this 8 and this 8? No, because there are two terms here in the denominator. Okay, and those two terms are getting added up. Okay, this is a term and this is a term. Whereas here we have only one term. Okay, if there are two terms, you should never cancel it out. Okay? Okay? Yeah, so only if it is a multiplication, then you can cancel this 8 and this 8. Okay, so can we further simplify it? So this is where ideas should come to your mind.
Okay.
How to simplify it.
We
You
have
need to use all your skills.
How to simplify
Make a common in x
Okay, how
plus
to
y.
take a okay. So let's solve one quadratic equation quickly. X square plus 3x plus 2 is equal to 0. Okay. So the very first step, you have to multiply the quotient of x square with 2, which you'll get 2. You need to write all factors of 2. 2 into 1 minus 2 into 1. So this is the right pair.
No,
If you add these two numbers, you'll get a plus 3.
no, it's not minus 2 into
Minus 2 into minus 1, yeah. Agree, yeah. Okay, so let's x square plus 3x can be written as a 2x plus 1x
2x plus 1x.
plus 2. Okay, the 3x we have written as 2x plus x. Okay, so in these two terms we can take x common. When you take x common, x plus 2 you'll get it. And in these two terms, what can you take out common?
1
1. You can take a 1 as a common. Yeah.
x plus
In
2
such case, you'll get 2. So what is the next step here?
x plus 1
next
How do you get that
x
step?
plus 1
Two
square
x
brackets
square plus
2.
2x plus
How do you get the next step you said is x plus 1 into x plus 2.
Yeah,
How did you get that step?
we have to take a
Common. What can you take a common?
x.
No.
X
To take x,
and
what
1.
do you get? You simply multiplied it, writing the next step, but you don't know how to get the next step mathematically. In this step, the very next step, you have to take x plus 2 as a common, isn't it?
Yeah,
There are two
I
terms.
know.
There are two terms. This is one term. This is another
Oh.
term.
x plus 1
In both terms, we have x plus 2. take x plus 2 as a common. When you take x plus 2 as a common, you put this kind of bracket. For the sake of simplicity, you will get x
Plus 1.
plus 1.
Ooh.
This is how you will get x plus 2 into x plus 1. Okay, x plus 2 into x plus 1 is 0. X plus 2 is 0. Either this can be 0 or this can be 0. Okay, so x is minus 2, x is minus 1. Okay, same technique you need to apply here.
So x plus y we can
The
take
same
yeah.
technique
x
which I
plus y we
explained
can take
here.
common. X plus y a minus
X plus y you can take it as a common. If you
Yeah,
see
so
carefully, this is one term and this is
x
Really?
minus a is yes daddy x.
okay. X plus y you can take it as a common in these two terms. Okay, this is consider this as one term. Though there is a plus here, you can consider this as a term because this is one term and this is one term.
And I said that to square
X plus y a minus c.
Okay. Yeah, take x plus y as a common. In that case, what do you get? A.
a
Minus c.
minus c.
Very good. And
By
the down in the denominator, what can you take
x
out
plus
from?
y
X plus y. You can
a
take
minus
as
c.
a
A plus
common.
c.
A plus c.
Now x plus y get cancelled.
X
A
plus
minus
y.
c by
X plus y gets cancelled.
a minus c by a plus c.
A minus c by
A plus c.
Can you further simplify it?
Mm.
Can you strike off A and A? No, you
No.
cannot take. Can you strike off C and C? You cannot do that either. Okay, so this is the simplified form of it.
Mm.
Okay, we need to apply the ideas. For example, these two terms, though it look like very complex, like we have A, we have X, we have plus, we have minus. Okay, the mix of symbols, mix of signs, mix of
Mix of
variables
different
here.
variables.
Okay, but if you carefully divide each section, take this part at a time. You can take something common. Take this part at a time. You can take something
In that
something common.
starting one I said that it and
Okay, maybe I did not hear. Yeah. That's good.
and also I said there's square brackets also.
Okay, very good. Yeah. Good then. Yeah. Good to go. All right. Okay. So let's move on.
Can you teach C?
Okay. We'll quickly discuss a binomial expansion.
Yes.
Any algebraic expression in the form of x plus y whole to the power of n. Okay. So before we move on, x minus y, we can also write it as a x plus of minus y. Is that right?
Yeah.
Okay. So there is no problem. Like if you learn x plus y whole square, what is the formula for x plus y whole square? X square plus 2xy plus y square. Sorry, 2xy plus y square. If you know this formula, using the same formula, you can also derive the formula for x minus y whole square also. How will you do that? See here, x is here. This can be written as x plus of minus y whole square. What is x? Compare this formula here. X is x here, plus is plus here. Instead of y, we have minus y. Same way, instead of y, you put a minus y in this formula. Let's put it. Okay? This one, x plus y whole square, we can compare this one, this expression with this expression. Both are same only, but there is only one difference. Plus x we have, plus x we have. Plus here, plus here. Here we have y. Instead of y, we have a minus y.
Yeah.
Okay? So let's use the same formula to find out the value of this x minus y whole square. How do we get? X square. X is x only, there is no difference, x square. Plus 2x only. Instead of y, because we have a y here, we put y here. So what is there in place of y here? Minus y. Plus y. Instead of y, what do we have here? Minus y. Minus y whole square. Okay. If you further simplify it, x square plus into minus minus 2xy minus y whole square
plus y.
plus y square.
Yeah.
Okay.
Plus y.
Plus y square. So this is plus y square. Okay. So what I mean to say is, knowing the expansion of x plus y whole square, you can easily find out the x minus y whole square also. It's not only for the square, but you can also find out the cube to the power of 4, to the power of 5, to the power of 6 also. Okay, only difference is instead of y, you need to put a minus y here. Okay. Okay. So any expression in this form, x plus y whole to the power of n, where n is a some integer value. Okay, it cannot be 2 by 3, it cannot be 4 by 3, it cannot be minus 1. Okay, it can only be 0, 1, 2, 3, 4, 5, 6, 7. If it is 0, you know it. X plus y whole to the power of 0 is what?
1.
1. Yeah. If it is 1, x plus y whole to the power of 1 is
0. X plus 1.
no,
Wait, 1.
x plus y.
Oh,
That's
X
what
plus
I
1.
X plus y. Yeah. So any expression in this form, we can expand it using this formula: nc0 x to the power of n, nc1 x to the power of n minus 1 into y plus nc2 x to the power of n minus 2 y square plus so on and plus ncr x to the power of n minus r y to the power of r.
R is a middle term, no? Like middle.
It's not a middle term.
Like
Okay, it's not a middle term. We'll consider this as a general term, or we can consider this as a r plus 1 term. Okay. 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 So before we discuss about this one, say for example, a plus b whole square is a square plus 2ab plus b square. Similarly, the similar lines, you might be knowing the formula for a plus b whole cube also. 3a square b, 3ab square plus b cube. See what is the power here? 2. How many terms we have here in the expansion?
3.
3 terms are there. Similarly, what is the
3.
3? So how many terms are here? We have
4.
This is one term, this is one term, and this is one term. A term is something that is separated with the plus or minus symbols. Okay, because we have plus, because we have a plus here, all of them are plus only. Okay, so if you have a power n, you will get n plus 1 terms. That is why you see here 0, 1, 2, so on, and the finally you got a NCN. So which means there are how many terms?
n plus 1.
N plus 1
N
terms,
plus
because there is a, it started with a 0.
N is infinite, no? Like how many times it can be?
No, n is limited by this n.
Oh.
If I put x plus y whole to the power of 6,
Whole number of
6 is
terms
the
are
n.
7. Whole
Six
number of
is
terms are 7.
yeah, the number of terms are 7, but the n in place of n we need to put a 6. Okay, okay. So NCR formula, you know it. The formula for NCR is n factorial by n minus r factorial into r factorial. You know how to calculate this one. This one is a one term. This is another term. This is another term. So on, the terms continues. Okay, because we don't know n. What is the value of n? That is why I put it dash dash dash. Okay, this is the general term. You can consider it as a general term or r plus 1 term. See, for this is
0.
what term is this? First term.
First term.
That is why we have 0. This is second term.
1
We have. This is the third term. 2. So like this, which term is this one?
R plus, sorry,
R plus
R
1
plus
term.
1.
That is why we have 1 less here. If you reduce 1, if you deduct 1 from r plus 1, what do you get? R. You will get r. Okay. So this is r plus 1 term or a general term. This is the last term or n plus 1 term. Okay. In total, we have n plus 1 terms. That is one observation. The second observation, see here, in the everywhere here, the top is n only. Okay. The bottom, if
I
you
have
see,
a doubt.
yeah,
For NCR formula, what is NCR formula? N factorial
by n minus r factorial into r factorial.
That n minus r factorial is n minus the factorial of only r.
No, n minus r, you have to compute n minus r first and then do a factorial of it. Okay. N minus r under bracket. Okay. N factorial by n minus r factorial. That's why I put a bracket here. Okay. Into r factorial.
We have to do
Okay.
brackets.
I put the brackets around n minus r factorial. No.
Oh no. You need to put a bracket to n minus 1, n minus r, and after that you need to put a factorial. Okay, so what are the observation? The very first observation, it has n plus 1 terms. Okay, if you see each term, there is a n here at the top. Okay, there is no change to it. What is this n? This n is this n.
And be like
Okay, and the terms started with
0.
yeah, and the
n.
down we have 0, 1, 2, so on, so on, so on, up to
Zero
n,
to n.
which means we have n plus 1 terms. That is one observation. And second observation is, take the power of x. The power of x is n minus 1, n minus 2, n minus r. What is the power of x here?
0.
0. That is at the very beginning. Can you write 1 in terms of x? You can write x to the power of 0.
And the first term,
In the first term, what is the power of y?
0.
0.
0.
Power
Okay.
of x is n.
That is another observation. The power of x is gradually reducing by 1
Oh,
every passing term.
that's why.
Similarly, the power of y is increasing. Here we have power of y as 0, 1, 2, so on, and up till n. Okay. Also, that is one way of remembering. The power of x will decrease, the power of y will increase. Okay, that is one way. Other way of remembering, the power of x is always the difference of this one and this one, n and r. That is why in this term we have n minus 1. In this term you have n minus 2. Here n minus r. Here
And
power of x is n minus n.
is
What is that?
0.
0. That is why x term got eliminated, because x to the power of 0 is 1. Okay, that is another observation. The other observation is, the power of y is all, this value of r will be the power of y. See 1 here. What is the power of y? 1. What is the power of y here? 2.
2.
Same. What is the power of y? R. What is the power of y? N.
N.
What is the power of y here?
0.
0.
Zero.
Yeah, because we have 0 here. 0. Okay, that's how you need to expand a binomial. This is called a binomial expansion. The reason why it is called binomial is because there are 2 terms here under the bracket.
Yeah, then there are like a 3 terms not there.
If there are 3 terms, that is, yeah. The way you should expand it is, consider two of the terms as a single term, and then you expand it later on. Okay, for example, if there is something like this, x to the power of n, you can consider this as a y, together as a y. Instead of y, you put this value. You put this value, you put this value, expand it. And in the next attempt, you have to expand again this one. Okay? The number of terms, like a huge number of terms will be there. Okay? Yeah, I think the number of terms will be, I don't know whether I'm right or wrong, but the number of terms will be n into n minus 1. For example, here if the power is 6, there are 7 terms. Okay, if there are 3 terms like this, if the power is 6, you will
Minus
get 6 into
3.
5, 30 terms.
30 terms. Oh, okay.
Huge number of terms, right?
30.
I'm guessing this might be the formula, but yeah. But when you expand it,
Why
you really get a very huge number of
NC0 is
terms.
given as first term?
Sorry?
NC0 is first term, right?
NC0 is not the first term.
No,
NC0
NC0
x to the power of n is the first
Why
term.
is that given first term like 0?
Because this is the formula this is the formula.
That is the formula.
Formula that you need to remember. Okay? Yeah. The benefit of this formula is that even if there is 100, you can derive like the 50th term you can find it out, 45th term you can find it out, 40th term you can find it out. Okay? You can as well do it with the Pascal triangle, but the Pascal triangle you need a lot of space to derive the triangle
Yeah, it will be so
for a
hard
power
to
of
draw.
100. Okay? That's fine. Okay, we'll
Teach
see.
Pascal triangle also.
Yeah, sure. Yeah, I will. For example, I have P minus 2 by Q 4 to the power of 33. Okay, I have one expansion like this. I have one expression like this, and I want you to find out 23rd term. How many terms is going to have first of all?
24. Sorry.
34.
34.
34.
What?
Because we have 33.
Oh,
we're
I
gonna-
thought actually you
No,
wrote
no, it's 33. Okay.
23.
That's fine, yeah. So I'm asking you to find out the 23rd term. Find out 23rd term
Mm.
of this expression. This is an expression. Okay, you need to find out.
Maybe take away.
Okay, I don't want you to find out all the terms, all 34
Just
terms,
23rd term.
but just a 23rd term or one term.
Maybe who can write all of those and find. Oh, I think it's like an.
NC.
Yeah, apply
NC
this formula.
NC
Like this is the
23.
general term that I said. This is the general
NC
term.
23.
NC.
23.
What is NC again? N 33.
Oh, 33C. Oh, 33.
33.
Okay.
C
33C 23.
22. Because this one I said R plus 1 term. For R plus 1 term we have R here. For first term we have 0. The second term we have 1. That means we are reducing it. For the third term we have 2 here. For a 23rd term, what should we
22.
have? 22.
33C 22.
33 C22.
Like that. Bracket.
P to the power of, what is the x? In place of x, what do we have here? P. P to the power of
33 minus
22.
22.
33 minus
N.
22.
Yeah.
Okay, n minus
minus 2 by q.
What is y here? Minus 2 by
Minus
q.
2 by q to the power of
Minus 2 by
22.
q
to the power of 22.
to the power of 22. So whatever we have here, that should be given to the power of y. The difference of these two should be given to the power of x. In this case, x is p, y is minus 2 by q. Okay, let's simplify it. 33C22, you can use the calculator. Okay, it's going to be very big multiplication. So you can use the calculator, or you can as well leave it here if you don't want to simplify. That is also fine. But let's take this one. P to the power of, what is the value of 33 minus 22? That is 11.
11.
Minus 2 to the power of 22. It's going to be
Wait.
2 to the power of 22.
Oh yeah.
Isn't it? Because this is an even number, even power. This minus will go away because minus into minus is plus. Again, minus into minus
Then
into
by
minus
q.
into minus plus.
By q.
By
Q.
q to the power of 22.
Oh yeah.
This power goes to this minus 2 and also q. Okay, don't ignore that fact. Okay, so this is one number and this is one number. You can put them together, or if you have a calculator handy, you can simplify it. That is fine. But these are the two variables. So p to the power of 11 by q to the power of 22.
Yeah.
Okay. So these things you can calculate using. This is all one term. Okay. Don't think because we have a p here, q here, there are multiple terms. This is all one term. What is the term?
That
23rd term.
23rd
23rd term. Because it is 23rd term, we reduce the r by 1. Okay. Okay.
Yeah.
Okay. So there may be questions, sir. Give me the expressions given like this. Which term has a p power 11?
X.
Oh. How are
Okay.
you going to find it?
20th.
So in that case, we don't know the r. In this case, we already know the r. That is why we simply put the r.
Instead of p.
Instead of 22, you put r and equate. You'll get something minus r, something minus r here. Equate the power of p to 11. You'll get the value of r. Everything is known.
33 minus 22 is 11.
Correct. In case if it is not known.
Yeah.
Yeah. For example,
Just
maybe-
cross checking. Just
yeah,
cross checking.
something like this. There can be something like this.
P, P are same.
Okay. So let's do that as well. Find the term in this expansion. In this expansion, where we have p power 11. P power as 11. Okay. See here, I put P here, I am also putting P here. Okay. Find the expansion in which we have, find the term in this expansion where we have a P power as 11. How can we find it out? Let's put the general term. We don't know what term it is. So, what we have to find out? We have to find out the R.
Okay.
How do we know the R? R, so that in that term we have a P power as 11.
Unknown.
So, N is known to us. What is N?
N is
33 C R P power 33 minus R. What is this one? Y?
2 by
2 by P
P
power
power R.
R. R. Okay. So 33 C R. R we still don't know. Okay. How do we find out the R?
How did you get R for minus 2 by P? Like.
I said na, for this one Y, this goes
yeah.
here, this goes here, this goes here, this goes here. Okay. Okay. For power of X, it is a difference of these two, N minus 1, N minus 2, N minus R. Okay.
Yeah.
So if you simplify this one, P to the power of 33 minus R. Okay. Minus 2 to the power of R. If you take a P to the numerator, you get P to the power of
Wait, no.
minus R.
Yeah.
Isn't it? Minus R. Okay. Can you further simplify it? You can simplify it. 33 C R. Bring this to this side. Not to this side, but because eventually they are going to be some constants. This is one constant, this is another constant, which you can find it out later. P to the power of this and this you can simplify it. P to the power of 33 minus R minus R.
Plus R.
No.
No, sorry. Minus 2R.
Minus 2R. Because the bases are set, you need to add the powers. Minus 2R. So what is the condition here? I asked you to find out the term in which we have a P power as 11. So what do we have P power here? 33 minus 2R.
Yeah.
So what is the next step?
Next one. Wait.
What is the next step?
So 33 CR minus 2R without bracket.
But we need to find out the R. How can we find out the R? So what is the question? Find out the term in which, find out the term in this expansion.
Equate P to 11.
Hmm?
Equate P to 11.
No. P power as 11. So equate 33 minus 2R to 11. Okay. Then only you'll get a P to the power of 11, right? Only if this becomes 11, then only you'll get a P to the power of 11. Isn't it? Okay, so let's equate this one to 11. 33 minus, okay, let's do it here. 33 minus 2R is equal to 11. So, if you do it, is equal to 2R. Can we do it this way?
Yeah.
Okay, so 22 is equal to 2R. R is equal to 22 by
It is 11.
R is equal to 11. R is equal to 11. We got R is equal to 11. What is the term? R is equal to 11.
No,
The term
P to the power of 11.
No, P to the power of 11 we got it here.
Oh,
Okay, but
instead
which
of-
term?
instead of
If I put R as 11 here, which term is it?
put the power of P as, you ask a term,
Term.
put the power as for P as 11
Hmm.
and find it.
No, I already have a P to the power of 11. I have it here. But which term? R is 11. In that case, what term is it? It is a 12th term.
10th.
12th term.
Oh, yeah.
Okay. This is R plus 1th term. Okay, if you have R as 11, that means
11 term means 10.
12th term. We are reducing it here. R plus 1 term, you are putting R as a,
Yeah. 10.
R as a, yeah. R, for r plus 1 term, you are putting here r. For 12th term, we are going to put r as 11.
11.
So that is a 12th term.
Or 11th means 10.
No.
I always get confused. Like
See, that is why you compare it here. So what is r here? Which term is this?
first term.
First term. What is r?
0.
0. Which term is this?
1.
What? Second term.
Second one.
What is r?
1.
1. Okay, so how can you find
Oh,
out the
11
r?
means oh.
How can you find out the r?
R is
Term minus
minus 1.
term
2 minus 1.
term minus 1. This is the second term. 2 minus 1, you get 1 here. Okay, so the r is 11. That is, it is a 12th term. He asked you to find out the term. Find the term in this expansion where we have p power as 11. So, this is a 12th term. Okay, so what is that term? 33 c 11 minus 2 to the power of 11 p to the power of 11. Anyway, you will get a p to the power of 11. This one we equate it to 11, right? So if you simplify this one, this part you can simplify it using calculator. This part is anyway having a variable which you cannot simplify it.
Yeah.
Okay. Okay. So tell me x plus 8 whole to the power of 9. How many terms is going to have? 10 terms. Okay. X plus
Yeah,
y
ask
whole to the
like
power
this.
of 1 by 9. How many terms it's going to have?
No, it can't be.
It can't be. Okay.
Yeah.
This expansion, this binomial expansion, you have to use it only if n is an integer. Okay. Positive integer.
What is an integer?
1 by 9. I said 1 by 9.
Oh.
Okay. You cannot use
it is
this
one,
one even for negative numbers.
If it is 1,
For 1 also
Why
you can
it's
use
gonna
it.
be?
how about
One
0th term will come now?
Hmm?
0th term will come.
For 1, how can you use it?
Put
1
the
C
power
0.
as
1 C 0.
put n as 1.
1 C 1. There are only 2 terms.
Oh.
Okay. What is the value of x plus y whole to the power of 1? X plus y only. Even if you use this binomial expansion, you will get there only. That
Yeah.
only. Okay. So that's important. Okay. So I'm going to give you in one expansion, we got something x plus y whole to the power of n. We got something like 33 c 22 x to the power of what? What do we get? Assuming the x is the first term here.
21.
21. Sorry, 11. What is y power?
My power is
22.
22.
Okay. Yeah, so you need to closely notice it. The power of x is decreasing, but that is one thing. Secondly, the difference of these two is taking as the power for x. Difference of these two, n minus 1, the difference of these two, n minus 2 is going as power for x. Similarly,
Then how did it get here?
11, the difference of these two, 33 minus 22.
Then
N minus r, difference of these two. Okay, na? N minus r. Okay. So what is the power of x here?
power of x is 0.
0. Very
Zero.
good. What is the power of y?
N.
Why we put only n? Why not n plus 1 or why not n minus
Because
1?
it's
Because, that is-
the last term.
No. Okay, last one that is fine. But because we have down here n, you are putting, this goes, the one at the bottom goes as a power for y. Okay, the difference will go to the power of x. Okay? Yeah. Alright, yeah. Before we wind it up, do some quick simplifications. Okay, can we simplify this one? We can simplify it.
Yeah.
So how can we simplify it? Is there anything that we can take out common?
Take it.
Common.
Is that 9 or a?
9b.
9b.
Oh, take common as 3.
3. Yeah.
A minus 3b.
3b.
And
Can we
take common.
something?
Take common as maybe 6.
6. A
A minus 2b.
Yeah.
3, 6
6 is
cancel.
18. This one gets cancelled, and this one here goes 2 times 1 by 2.
Yeah.
Okay.
1 by 2.
There's one thing you can do. A cube minus b cube by 6a minus 6b. Can we simplify this one? We can simplify it.
Yeah.
Remember we discussed, right?
Yeah.
The factors of a cube
It
minus b
is-
cube are a minus b into a square plus
B. No.
plus ab
Oh yeah, the one.
minus.
Plus AB minus B square. Yeah.
Is
Yeah.
that?
Yeah, that one.
Are you sure?
Yeah. Yeah. I am sure.
Yes.
Starting
No.
we did with the same one.
Really?
Yeah.
Sure. This is going to be minus here,
Hmm.
and if that is the case, it's going to be like this. Yeah.
Hmm.
This plus here. Okay. So here, can we take? These are the factors for a cube minus b cube. What are the factors of this one?
What?
What are the factors of 6a minus 6b?
One AB. No.
What are the factors of this one?
6A.
Minus 6b.
1.
6 and a minus b? No, take 6 as common first.
6 as a common, a minus b.
A minus b. Yeah, that's
So
what
what
I
are the
told.
factors? 6 and a minus b are the factors.
Yeah, that's what I told.
Okay. So a minus b gets cancelled, and you are left with a cube, a square plus ab plus b square
By 6.
by 6. Okay, this is the answer. Okay, so we also have factorized 4x square minus 81. Okay, we need to factorize this one. This is an expression given. We need to find out the factors of this one. Can we find it out?
Yeah.
How?
Yeah, me 4x square plus z is.
See, we have a square here. This is also seems to be a perfect square.
Ah,
So this
square-
one we have to
square
write
root,
it as a
square
square.
root, square root.
No. We need
Take
to find
4
the
as
factors of this one.
Take 2 as no 3 as
This seems to be a perfect square, right?
No. I need
9 square. This one can be written as. Can we write this as a
2.
square number?
2
square is 4.
2 into 2 square.
You can write this as like this. 2x whole square. Okay. Minus 9 square.
Oh. That one I'm saying.
Okay.
Hmm.
So in which form is this in?
A square minus b square.
A square minus
A
b
plus b
square.
into a minus b.
A plus b into a minus b. What is a here?
2x
Two.
square. Sorry, 2x.
2x plus 9 a plus b into a minus b. Okay, these are the factors of this expression.
Yeah.
The given expression is 4x square minus 1.
Yeah.
Okay, so you need to see by looking at it, this should strike to you because we have a minus here. That is the first thing. Secondly, this seems to be a perfect square number, 81. You can write it as 9 square.
Yeah.
And this also you can write as a square of something. What is that thing?
Square
2x whole square.
Yeah, it is perfect square root.
Perfect square, yeah. So there is also another one. 15 AC minus 12 AD minus 12 AD minus 10 BC minus 10 BC and plus 8 BD. So we need to find the factors of this one.
Find the common of it.
Can we take anything common in these two?
A.
Okay.
In these two a,
A.
In these two A. Is there anything else that we can take out common?
maybe 1. No,
3.
3 table, right?
Yeah,
It goes in 3 table. Yeah. 3a, take 3 as a common. You're left with 5c minus
and, 6.
4d,
Yeah, 4.
isn't it?
Mm.
Here, can we take something common?
B. No.
b,
2B.
2b minus 2b.
It is 5C
5c.
plus 4D.
Y plus
Sorry, minus
minus 4d.
Yeah, it came same one.
This one,
And
this
then
one is.
square brackets.
Yeah, very good. Yeah, same thing. 5c minus 4d into 3a minus 2b. Okay, so these are the factors.
Yeah. And then square brackets.
Not necessarily. That's what I said, right? If you want to put
You
square
said
bracket, you
that
can
we
put square
have to
bracket.
put square brackets.
Square bracket I put just to distinguish what we are taking out common.
Okay. So those are the.
These are the factors.
Hmm?
Okay, even if it is so lengthy, you can simplify it this way.
Yeah, it seems like so big.
It seems like so big, but when you start doing, it's down to
Hmm.
factors like this. Okay. 25x square minus 49y square.
Hmm.
25x square minus 49y square. See, there are a number of problems in this format, a square minus b square. But the only thing you have need to do is that you need to identify what is a and b here.
No, it is x and y.
X and y are a and b. A square minus b square, the formula is a plus b into a minus b. Okay, there are a number of problems given in the same format. Okay. So, how can we write this one? How can we rewrite this expression? 5x
5 square. Yeah.
whole square.
And
Don't put it as a 5 square.
y.
Instead of that, you
whole
put a 5x
square.
whole square.
Yeah.
5x, there is a multiplication, which means 5 square and x square. Minus
And
7y,
7y whole square.
7y whole square. So, what format is this in?
A square minus b square.
So,
A plus b into a minus b. 5x plus 7y into 5x minus 7y.
minus 7y.
Mm.
Okay. So, I have something like 7 minus y. Can we also write it as a plus b into a minus b?
No, 2.
Okay, alright, I'll do it like this.
No,
Yeah.
it is 2.
No. 7x square minus 5y square.
Oh.
Okay, find out the factors of this one.
A square minus b square. A plus
How?
b into a minus b. 7x plus 5y. 7x minus 5y.
What is a here?
7x.
7x.
Is 7x is
No. Oh, 14x square.
a? No.
No, 49x square.
7.
No.
7.
Wait.
7x square minus 5y square.
This is different. You can't do anything.
You can do it.
We can do it.
We can do it.
Oh.
Okay, this is not a perfect square number, but still you can do it. There is a way you can do it.
Oh yeah. Wait. 1. No. 3 square is equal
You
to
know?
9.
You know?
2,
Yeah.
4, 2 and 3. Yeah. 2 square. 3 and 2 square.
This can be written as
Square root. Yeah,
Oh.
but we have to do like.
put a square root. If you want to get a 7 after squaring, you need to put the square root of 7.
Okay.
Okay. Similarly, for 5y square, you can put a square root of 5y whole square. This is an a square minus b square format. You simply put that's it. Okay, so this is a trickier one, right?
Mhm.
Definitely trickier one.
No, it's actually easy.
Hmm?
It's actually
Okay. Alright, so we have an expression like this 5x plus 2y minus 8 is equal to 0. This is a linear expression having two variables. If an expression something like this is given, we can draw a straight line. To draw a straight line, what are the things that we need?
Slope.
Slope
and
we need,
Is
or
it
maybe
algebra?
2 points on a
Is it
line is fine.
algebra?
2 points on the straight line. So how can we find out the 2 points? Just put a tabular form like
Yeah.
this. Okay? Okay, x and y. Put value of x as 0, find out the value of y. Similarly, put value of x as 1, find out the y. And in the graph paper, find out those 2 points and connect those 2 points. If 2 points are given, how many straight lines can you draw?
1.
1 only. Yeah, you cannot draw two straight lines. Okay, then you can only draw 1. Okay, so this is an expression given. If you want to write this one in y is equal to mx plus c form, you put separate y to one side. 5y is equal to minus 5x plus 8. 2y, sorry, 2y. 2y, I left it on the left side only, and I took 5x and minus 8 to the other side. That's why they become this one. And not only this one, you also write y as a something. Okay, not 2y as something. Okay, y 5 by 2x
Plus 8 by 2.
plus 8 by 2. So this is minus 5 by 2 x plus 4. So this is an y is equal to mx plus c form. What is m here?
Is minus
Minus y by 2.
5 by 2.
What is c? 4.
4.
That means in y axis it's going to cut at a point 0, 4. And the slope of this one is minus 5 by 2. This is minus slope, that which means it's going to fall like this. While it's moving from left to right, it falls. The line falls
If you think it is means
like this. Yeah. So if I give another straight line, something like 2x plus 5y is equal to 9. Is this a straight line? This is also
Yeah.
straight line.
Yeah.
This is also straight line.
2x will
Okay. That another straight line may be something like this.
Yeah.
Okay. If there are two straight lines in a plane, can they meet each other?
Yeah.
They can meet.
Uh-huh,
There is only
no,
one
it
condition
combine
where they don't meet.
That one.
There is only one condition where they don't meet. What is that condition?
If there are like wait. If
The railway
there-
tracks will never meet. What is the condition there?
Par.
Because they are parallel.
Yeah.
Okay.
Parallel.
The m here represents the slope.
Mhm.
What are the units of slope?
Units of x.
Nothing. No units.
No units. Yeah. In a coordinate plane, there are no units. If
And
you
then-
draw a equation like this, there are no units for slope. But if you
X
put
and
something like a time here, if you put something like a distance on the y-axis, then the units will be
What is x?
Speed.
And what is
meters
y?
per second, because the distance is in meters or centimeters and the time is in seconds, minutes, hours, anything. In that case there will be units, but in this case it's just straight, a plain straight lines. Okay, x-axis is x-axis only, y-axis y-axis only. We are not putting any quantity on x-axis, we are not putting any quantity on y-axis. Okay, so if equation something like this is given, the slope unit is none.
Then
Okay. Because y-axis is also units, centimeters. X-axis also centimeters. Centimeter by centimeter gets cancelled and there are no units. Okay, if another line is given, you can draw another. If another straight line equation is given, you can draw another straight line, and those two lines will meet at one point, provided they are not parallel lines. If the two lines are not parallel, they will certainly meet at one point. They must meet at one point. Okay, there is no doubt about it. Okay. They may not meet in this board, but somewhere down, up, somewhere they surely meet. Okay? But the condition is that their slope should not be the same. Okay? Yeah. Teshni, you tell me if there are 2 points are given on a straight line, how do you find out the slope? Say for example 2, 1, minus 5, 8. What is
Instead
the
of
slope?
x, put something. Instead of y, 2 points are given. Instead of
2 points on a straight line is given, and you are asked to find out the slope of that line.
y is equal to mx plus c, no? First one is y is equal to 1, no? Put that and m put to 2 like 2.
No, you are making too complex. y2 minus y1 by x2 minus x1. This is the slope.
Yeah.
Oh.
Yeah.
Okay.
x1
Yeah.
y1 x2 y2.
Fundamentals. Okay. Don't miss out these fundamentals. Y2 minus y1 by x2 minus x1. Okay. Two points are given, and you're asked to find out the slope, the line equation. How many lines will be there how many lines can be drawn connecting 2 points?
One.
Connecting 2 points, how many lines can be drawn?
One only.
One only.
Yeah,
Yeah.
one
So there will only be one straight line equation. How do you find out that straight line equation?
Y is equal to
I.
M, you got it using this one, y2 minus y1 by x2 minus x1.
Yeah.
So what is the next thing that you need to find out the straight line equation? C is the something that you need. To find out C,
Square root of.
y is equal to mx plus c. Pick up any point. Put value of y
Maybe.
here. Value of x is here. The value of m you got here from this one, and you will get to know the c. Okay, you'll get to know the c. After that, now you have m, you have c. After that, writing equation is simple. Y is equal to mx, whatever you get m here, you put here mx, plus whatever you got c here, you put that one here. Okay, so that is the straight line equation. So the number of questions you can ask, like 2 points are given, find out the slope. 2 points are given, find out the straight line equation. A straight line is given, find out the slope. Okay. There's not too much of complexity, but only few variables are there, but you need to know how to manipulate those variables to get the things that you require, that you're asked to find out. Okay. All right. Yeah, we'll leave it there for today. Thank you. Stop it, please.